All right, guys, sorry about that. So we're going to number 1 right now. Just please indicate before I start that you see my screen.
Yeah.
Okay, great. So we're going to work number 1 question now. Let me find a book real quick. All right, perfect. So as you can see, the questions P bracket T on T, then I'll look right. Close bracket equal to P 0 bracket 1.12 raised to the T. Now this is also the equation that was given, right? And the question asked us to find the predicted price of a 20 kilogram bag of rice, presently costing $8,000 after 5 years, right? And in order for us to determine that, all we're going to do is plug and chug, right? Substitute the values that were already given in the question in the equation that was provided, right? So what are the values that are missing? We realize that the unknown variables are T and P naught, right? So T is equivalent to years. So we're going to find the years that was provided to us in the question, right? And it's right at the last sentence where it says, find the predicted price of a 20 kilogram bag of rice, presently costing $8,000 after 5 years. So then we can determine that T is equal to 5 years, right? And then we have P naught. What did it say is that P naught is equivalent to? It says that the function, which is given above, yields the predicted price of PT after T years of an item that presently costs P naught. So P naught is the present cost, right? So then we're going to search for in the question if they gave us that figure, right? And we can see at the last sentence as well, where it says, find the predicted price of a 20 kilogram bag of rice, presently costing $8,000. So that $8,000 will be our P naught. And then we can write it like P, wait 1 second, is equal to $8,000. So now that we have all our unknown variables solved, then all we need to do is to plug it in the equation given and then solve for the answer. So then we can say P bracket T, which is equivalent to 5, is going to be equal to P naught, which is $8,000, bracket 1.12 raised to the power of T, and we also determine that T is equal to 5, right? So all we need to do now is to plug that in our calculators. Just plug it in nicely in our calculators, and the answer that we will arrive to is that P5 is equal to 1, 4, 0, 9, 8, 1. All right, this better.
Yeah.
Oh, give me a second, guys.
Yeah.
Yeah, sorry about that, guys. So that is equal to 14098.73. Now I think it's a multiple choice question, that you guys will be given, but it's very important that we don't leave off our units, multiple choice or not. It's something that you should always practice, right? So what did the question ask for? It asked us to find the predicted price, right? So we want the price. So you know that the unit that we'll be using is $sign. So this, so we have the 14,000. So $14,098.73. So that is our predicted price. And that is question 1 completed. All right. Oh, give me a second to see if we can fix this up real nicely. Okay. All right, cool. So now we can go to number 2. Let me just clear the board and just pull up number 2 question. All right. All right.
Remember that we're not getting matrices on the finals.
Oh,
We
you're not.
can skip over that one. Yeah, we're getting
Oh,
from limits. Yeah, the limits, differentiation, marginal functions,
okay, cool.
basically.
So we don't have to do the entire paper then. Okay, great. All right. So here we have a very nice differentiation question. All right. So it already gave us the product rule and the quotient rule. These are very important for us to know. Not sure if they still do this. When my year they gave us on the exam paper, but I recommend that you guys know these by heart, so you don't really need to flip back and forth to write about the formula and input it in whatever question that you get. All right, so it's important to know the formula, as well as not just the formula, but the different functions that we have in differentiation and how to derivate those functions, right? So the first question, we have f prime x for the following functions, right? You need to find that. And we don't need to simplify our answers, right? So we have in the first one, f of x is equal to 3x squared plus 1 all raised to the power of 4, right? But before we actually do the differentiation question, let's just first write down the basic functions that we usually ask to differentiate and the differentiation of them. All right. So we have the general function, which is x on, all right, it's better, x raised to the power of n, right? I'm on the n and I look right at all. X raised to the power of n, which is the function. So f of x, let's just put this at the top. F of x, and then should I carry this down like a bit? All right, cool. So we have f of x, and then f prime x, right? Just a general differentiation. So we all should know this one. Pretty simple. X raised to the power of n, and the differential of that is that we carry down the power, which is n, times the x raised to the power minus 1. So subtract 1 from the power. So n minus 1. Simple differentiation. And I'm sure everyone knows this one, right? We are also sometimes asked this one, where we have a x plus b all raised to the power of n. And we see this look very similar to the question that we just asked, right? And to do this is relatively simple to what we did above, right? So we carry down the power, -1 from the power, but we don't stop there. We also find the differential of what's in the bracket, right? So carry down the power of n, a, guys, excuse the bad handwriting. But yeah, I think we all can make out what's being said here. So a x plus b all raised to the power of n, that's n minus 1 minus 1, and we times that by the differential of what's in the bracket, right? So differential of ax. So we can just say n times a, because anything raised to an unknown variable that's not raised to anything greater than 1, for instance, it doesn't have any power, so we automatically know that it's 1. Then it just gives us back the number that's before the unknown variable. So in this case, it will just give us back a. So we can put back the a right here. So a times n, right? And we can just go about 2 more, because I don't think the questions go any further than the other ones. Because I don't think at this level you need to know the cost, quotient and cosec, and the arc and the rest of those stuff, right? Just the 4 main ones. So we're just gonna go 2 more. So we know the E1, we raised to the power of x, the differential of that is gonna be the same. One. Differential of e raised to the x is the same thing as e to the x, right? And why is that so? Because with e to the x, we always differentiate the power, and after we differentiate the power, we carry down the power, and then we write it back just the same. So in this case, what did we say before? If we have x not raised to anything greater than 1, in this case, it's just raised to 1, and we can automatically assume that a 1 is before it. It will just give us back 1, right? So just give us back e raised to the power of x. And the last one, we have ln x. So L n x, and the differential of that, how we find the differential of ln is that, I'll put this in brackets, right? For ln functions now, to find the differential of those, we find the differential of what's in the brackets, divide that by what's in the bracket. So the differential of what's in the bracket is x. We all know the differential of x is equal to 1 divided by what's in the bracket. What's in the bracket is just x, and that's the differential. All right, so we can clear the board and we can work the first question. Now that we have all of that out of the way. Cool? All right. So I'm gonna just find out the first question and then write it up on the board, so we can run through it real quick. And guys, don't let me be the only one talking. If you genuinely don't understand something that I went through, feel free to mic up or just type it in the chat so I can clarify. All right. All right. So we can put this on the board now. All right. So we have number 4, which says f of x is equal to, open bracket, 3x raised to 2 plus 1, all of that raised to the 4th power, right? And it's asking us to find Find f prime x. Cool. It's asking us to find f prime x, otherwise known as the differential of x, right? So in the basic differentiation functions that we just went through, we can see that this looks very similar to the second one that we mentioned, right? Where we have two different more than one functions in a bracket being raised by a power, right? And to do this, we said that we carry down the power, minus 1 from the power, and then just find the differential of what's in the brackets, right? So we're going to do that right now. Cool. So we're just going to carry down the power to find the differential. So the power is 4. We carry down the 4. Then we times it by what's in the bracket, which is 3x squared plus 1 minus 1 from the power. 4 minus 1 is what? 3. Multiplied by the differential of what's in the bracket. All right. So what's in the bracket? We have 3x squared plus 1. We're going to do the same thing like the basic differentiation. Carry down the power minus 1 from the power, right? So in that case, we're going to have it multiplied by 6x. Because it's the whole number, it's automatically going to be 0. Well, not automatically. It's going to be 0, right? So this, we don't need to write it back. So in that case, we're going to have it equal and put the equal sign. We're going to have 6x4. So 6 times 4 is what? 24. 24x multiplied by 3x squared plus 1 raised to the power of 3. Cool? No tricks. Relatively simple. Sure everyone understands so far. If you don't understand, feel free to let me know. Mic up, type it in the chat, because we're all here to help each other. All right? All right, so that's the first one. Let me see if I can move this over so I can write number, well, part 2 right beside it. Okay. Oh, no. All right. Carry this up. Carry it right here. Cool. All right. So that's part 1 for question 4. Let me just fix this. Yeah, man. Part 1 for question 4. So now we're at part 2 now. Let me just fix this right here. So. All right. So part 2. Part 2 asks us to find the differential of f of x. Boy, these x just look like I'm gonna go through some rough. All right, f of x equal to x times ln, open bracket, 4 minus 5, 5x. Zin? All right, and it's asking us to find the differential of this, which is f prime x. Cool? So what did we say about ln function? To find the differential of an ln function, all we need to do is to find the differential of what's in the brackets divided by what's in the brackets, right? So the first thing is what we look at, what the function is saying, right? But then we look at this, that it's more than one function. Well, not more than one function, but it's more than one. We have two different things. We have x by itself being multiplied by ln 4 minus 5x, right? So we can't apply the normal differentiation to this, because this is something being multiplied by another thing, and that is classified as product, right? Some product application are going there, so. And in that case, we're going to use the product rule, right? And the product rule is given as the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. Cool? So I can just write this right here, so. All right, I'm gonna just clear this off. Just put it right here, so. So it's a product rule. Oh, I think this is that easy. I'm gonna just use the text now. 1 second. All right, nice. So it's a product rule. Is equal to v, which is the second function, raised to, well, as x times the derivative of the first function multiplied by x plus the first function, x times the derivative of the second function. Cool. So now that we have the formula to carry out our product rule application, then we can actually apply it to the question and derive our answer. Cool. So we say that we label them. So we see the first function and the second function. We have two different functions, right? We have x, which is our u. Let me just change the color of this, make it easier. All right, let's make this red. All right, so we have our x, which is our u, and then we have our ln times 4 minus 5x, which is our v. Zine. So now we just need to plug and chug. Well, before we plug and chug, we need to find the differential of these so we can plug and chug. So we already know what vx is and ux, right? They're already given. They're right in the question. We just need to find the differential of the first function and the differential of the second function, and then we substitute the values, and then we simplify in order for us to get our answer, right? So we have our u, which is equal to, well, let's put u of x. U of x is equal to x, right? U prime x, which is the differential of u x, is just going to be equal back to 1, right? And then we go to v now. V of x is equal to ln 4 minus 5x. And then v prime is just the differential of that. So we said the differential of ln, right? Differentiate what's in the bracket and divide that by what's in the bracket. So find the differential of what's in the bracket first, right? So we say what's in the bracket? 4 minus 5. Whole number, differential of a whole number is just going to give you about 0, right? So this will be 0 right here. So 0 minus the differential of 5x, right? It's just going to be equal back to minus 5. Cool. So now that we have all our values, then we can plug it into our equation in order for us to get our answer, right? So I'm gonna just change what the color block, right? So now we can say f.
Hold on there. What did you say regarding the 0 and differential of the whole number?
All right, when you find the differential of a whole number, the differential of a whole number is going to be equal to 0. Always.
Oh, okay, bless.
Or is 0 and any other whole number. Yeah, man. All right. So now we can substitute the values and then arrive at our answer. So look back at the product rule. It says first the second function, which is v, and we already dictated that our v is equal to ln on ln 4 minus 5x, right, multiplied by our derivative of our first function, right? And what did we say the first function's derivative is? We see it right here at the top is equal to 1, right? So multiplied by 1, right? Plus, I'm gonna just fix this up neat for you, so it don't look that confusing. All right, let's put this in brackets. 1, see, plus our first function, which is x, multiplied, we'll come along right here, so now, multiplied by the derivative of our second function. And our derivative of our second function is also at the top, which is equal to negative 5, right? They say that we don't need to simplify, so you can just leave it like this. But I do encourage you to practice it to simplify, because you will be doing that in second year. No need to simplify that much though. So 1 times anything will just give us back the function. 1 times ln 4 minus 5x is just going to give us back ln 4 minus 5x. Just going to give back the same thing. And then x times negative 5 is just going to be equal to minus 5x. And that, folks, is our derivative of our f of x, f prime x, rather. All right. So cool. Any questions before we move on? Are everybody good? All right.
Hold on there. For the first one, I was distracted. How did you come by the 6x?
All right. So look at the function now. We see where it says f of x is equal to 3x plus 1, all that raised to the power of 4. That's given to us, right? And it's asking us to find the derivative of that, right? So based on the rules of differentiation, right, there are 2 functions in the brackets being added or subtracted. 2 different functions in the bracket, and it's being raised to a power. And based on the rule of differentiation, in this particular case, in order to differentiate it, you need to carry down the power. The power is 4. They carry down the power, and you multiply that by what's in the bracket, which is the 3x squared plus 1 minus 1 from the power. 4 minus 1 is going to be equal to 3. And then to arrive at the 6x, we find the differential of what's in the bracket, right? So the differential of 3x squared is going to be equal to 6x. Same thing, same principle. Carry down the 2. 2 times 3 is equal to 6. And then minus 1 from the power. 2 minus 1 is going to be equal to 1. So 6x. And we already spoke about the differential of a whole number, which is just going to be equal to 0. So that's how we arrived at the 6x.
All right, thanks. See,
Yeah, man, no problem. All right, so we can move on to the second part of the question. I'll just clear the board. All right, so the second part asks us is another differential question. All right, part 3 asks us to find the differential of this function. Differential of x equal to x raised to the 3rd divided by 4x minus plus 2. Cool. So that's the function that's given to us, and it's asking us to find the differential of that function. right? But then we realize that this is not a normal function that we can just carry down the power minus 1 from the power, right? This is a quotient. Well, it's been divided by something, so we have to apply the quotient rule, right? So the quotient rule as given to us is the second function, the square of the second function, multiplied by the second function times the derivative of the first function minus the first function times the derivative of the second function. And don't worry, I'll put it right here so on the board just as before, so we can all see how we're working it or what we're working it from, right? So whenever you see a function being divided by another function, you automatically will know that we have to use, you should know that we're going to use the quotient rule. We always use the quotient rule in this case if we have a function being divided by another function, right? In most cases, we'll use at this level at least, we'll use the quotient rule, right? So the quotient rule says, I'll put it right here. Let's type this in. All right, so quotient rule. All right, yeah, man. So quotient rule says, I think we should all know this by now though. So it says the second function, v x multiplied by the derivative of the first function, cool, minus the first function multiplied by the derivative of the second function. And all of that divided by the square of the second function. That's the rule that has been given to us. I'm sure everyone knows this rule, or should know this rule. Square, right? So now we need to identify what's our u value and what's our v value, our v function and u function, right? So our u function will be our numerator, and our v function is our denominator rather, right? So our numerator is x raised to the power of 3. So now our ux is equal to x cubed, and our v, which is our denominator, we can see where it has 4x plus 2. So we have our v x is equal to 4x plus 2. No tricks, right? So now we just need to find the differential of our u and v. Simple solution. Nothing too hard. We've been doing this since we started. So the differential of our u prime, our u differential, x, we carried on the power minus 1 from the power. So carried on the 3, 3x minus 1 from the 3. 1 from 3 is equal to 2, right? And then v prime, or the differential of v, same thing again. Carry on 1 from the power, minus 1 from the power, and then we'll just be given back 4, and the differential of a whole number is just going to be equal to 0. We don't need to put that back. It's just going to be equal to 0, right? So now that we have all our values, only thing we need for the right now, plug and chug, right? We don't need to find the square of the v. They're not gonna go so far with it, but we can do that though. But that's gonna be a little bit too time consuming right now. So we're just gonna work with it like this, right? So now we're just gonna plug and chug. So we say, all right, change the color of this now. We'll say, all right, cool. Since we have all our values, just need to substitute and arrive at our answer. right? So we have our f prime x dot, what we say our v is? Our v is equal to 4x plus 2. Bracket that, multiplied by u prime, or the differential of u, and we say that's equal to 3x squared, multiplied by 3x squared minus our u. Our u of x is equal to x cubed. And guys, please ensure that you always bracket them so that we minimize on errors. All right, and I'll tell you exactly what I mean by that afterwards. So we say our u of x is equal to x cubed. All right, the theory better. X cubed multiplied by our v prime, which is equal to 4. Right? All of that divided by the square of our v. All right? And we say our v is equal to 4x plus 2, the square that's, and then there we go. All right? And this is our answer. I don't really need to take it down any further. But it's good to always practice that though. All right, but for time consumption, we won't be doing that, so we can just leave it here. They say that you don't need to simplify. All right, so now we'll just go to our number 5 question. All right, so we can clear the board and now we're at number 5. So I'll just share number 5 real quick so we know where we're at. All right. All right. So we just finished number 4. So it's number 5. All right. So number 5 says a small manufacturer of keyrings estimates that when X keyrings are produced, the total cost in dollars will be, gives a function C of X is equal to 8,000 times E raised to the power of 0.02x. And it's asking us to find the marginal cost. And then afterwards, we don't go this first. All right. So whenever in this case it's asking us to find the marginal cost, it's asking us to find the differential of what's given, of the function that's given, right? And we can see that the function that's given is Cx is equal to 8,000 E raised to the power of 0.02x, right? So if it comes on the question asking you to find the marginal cost of a function, it's asking you to find the differential of that function, right? Nothing too hard. So don't make the question, sometimes they might word it long for you just to make you confused, but it's asking you just some simple stuff. It's just for you to reason it out and try to understand what it's trying to say to you, right? So for marginal cost, it's just asking to find the differential, right? So we can just write about the function. All right, so number 5, the function given to us is C bracket X is equal to 8,000 multiplied by E multiplied by E raised to the power of 0.02x. All right. So this is our function. I'm gonna fix the first part. This don't look right at all. All right. Cool. All right. So it's a C. All right. So it's a C is equal to that. So we're gonna find the differential of this, which is C prime. All right. So you realize that we have an E function, right? And we did this. This was one of the examples that we worked in the first part of the session, right? And we said that, for example, where we have e raised to x as our f of x, right? Put this back here, so, right? Where we have that is equal to our f of x, our f prime is just going to be equal to the same thing, right? So meaning that our f prime is going to be equal to the differential of what the power is raised by, which is x. The differential of x is going to be equal back to 1. And then we carry down the 1 and multiply that by the original function, right? So it's just going to be equivalent to 1 minus 1, sorry, 1 times 1 times e of x, which is the same as e of x. All right, no tricks. All right, so now we can, based on the general example, we can use our knowledge to work the question that's given. Right, so now we have 8,000 times e raised to the power of 0.02x. So in order to find the answer to this differential, we need to find the differential of the power of e, right? So we need to differentiate the 0.02x, right? And then after differentiate that, we carry down the answer and multiply it by the original function that's already given, right? So all we're doing is find the differential of the power and then multiply it by the original function. Nothing too serious, right? So the differential of the 0.02x is just going to be equal but to 0.02. Right? Multiplied by the 8,000 e raised to the power of 0.0. All right, hold on. I'm just copy and paste this. Make it easier, cause. All right. All right. All right, so that now work. I'm gonna start to work. Here, so. All right. All right, so it's 8,000. 8,000 e raised to the power of 0.02x, which is our original function. And we can just multiply the 0.02 times the 8,000, and that is going to be equal to 160, right? So we have 160. After we multiply that by that, it's going to be equal to our e raised to 0.02x, and that is differential of our c of x. Nothing too hard. If you have any questions before we continue, please let me know. All right, you can mic up or just type it in the chat. All right, no questions. All right, cool. So the second part now, all right, the second part, I'm gonna show the second part real quick. All right, so the second part, it asks us to compute the marginal cost when x is equal to 10 and interpret our results, right? All it's asking us to do is to substitute 10, where x is equal to 10, into our original answer that we just got, all right? We're just sub it in. We're gonna sub x is equal to 10 into this equation right here, our differential of c of x, right? That's all we're gonna do. So the second part, so when x is equal to 10, let's type this in. All right, so when x is equal to 10, then our c prime 10 is going to be equal to 160 multiplied by e raised to the power of 0.02 multiplied by our x is equal to 10, so let's write back 10. Oh, it's not correct at all. All right, our x is equal to 10. All right, so now you just plug this in our calculator. All right, 160 e raised to the power of 0.02 multiplied by 10, right? And you should get 195.42, right? So we should get our c to the power of 10 is equal to 195.42. That is our c. Our c c prime when equal to 10, right? Again, no tricks. Oh, guys, I can't believe you never reminded me about this, right? So remember that I said that it's important to whatever question they ask us to ensure that we put the units beside it, even if it's not asked of us. It's good practice, right? Because in the real world, you'll need to do that, right? So it asked us for, in the part I, it's asked us for a marginal cost. So then just ask to put the dollar figure. All right, cool. All right, this looks kind of small still, but let's fix that. Oops. Hold on. All right, cool. So we just put our dollar figure here. Make that a little bigger. All right. All right, now I'm just draw this right here, so because just to save time. All right, mod. So dollar figure here, and then the cost is asking us to compute the cost again. Dollar sign again. That's our units, and that will complete question number 5. All right. Again, if you have any questions, feel free to mic up, type it in the chats, or anything you need clarification on before we move on. All right. All right. Don't see any questions, so I guess everybody is good then. All right, perfect. All right, so we can move on to question number 6. Realize that things are relatively simple so far. Nothing too complicated. Trust me, guys, you guys can really do good on the exam. Just practice and remember the formulas that you're given and apply the principles. All right, so question number 6, we see stationary points. So it says we're given the function of f of x is equal to x cubed minus 6x squared plus 9x plus 1, right? And it's asking us to find the stationary points of f of x, right? So whenever it asks us about stationary points, we need to find the x values, right? Let me just pull out the whiteboard. Whenever it's asking us about stationary points, they're asking us to find the x values of an equation, right? So the equation is given as number 6. Equation is given as f on right better. F of x is equal to x cubed. No, it's not right. All right. All right, good. X cubed minus 6x squared, all right, plus 9x plus 1 plus 1, right? And it's asking us to find the stationary points. So find the stationary points. So asking us to find the stationary points of f of x. Let's carry this out. Cool. All right. So we said whenever they're asking us to find the stationary points, they're asking us to find the x values, right? So now, in order for us to find the x values, to make it easier on us, all we need to do is differentiate, so we can carry down the values a little bit more. It makes it much easier for us to work out our x values, right? So in most cases, at least right now, whenever they're asking us to find the stationary points, you'd realize that probably the function is has a power of 3 or so. So we need to carry it down, so we have 2, 1, 0, and a whole number, so we can find for x, right? So now we see our original function of f of x is given, so we find the differential of that, right? So the differential of this, our f prime x is equal to, same thing we've been doing this entire time, carry down the function, minus 1 from the function. So carry down the 3 multiplied by x raised to the power, right? Or minus 1 from the power, so it gives us back 2 minus 6, right? But before we put that 6 there, we carry down the 2. We carry down the 2, so we have 2 multiplied by 6x minus 1 from the function gives us back 1. We don't need to worry about that 1 there, right? Plus our differential of 9x is just going to be equal to 9. And the differential of a whole number, as we said before, is just going to be equal to 0, right? So we can just simplify this. It's going to be equal to 3x squared on 3x squared. 6 times 2x is equal to 12x. 12x plus 9 on. All right, cool. So now we have it simplified, right? So in order to find for x, we need to equate this to 0, right? Let's put this right here, so. All right. So this we need to equate it to 0, all right? In order for us to find our x. Equate it to 0, right? But guys, just a major tip: if you realize that we have we have yeah, if we realize that we have an equation where they have common factors, not really common factors, but something can be one thing can be divided by all things to make it a little bit simpler. In this case, we see 3 of x squared minus 12x plus 9. The smaller the number we're working with, the easier it is for all of us, right? So I realize that one thing all of these have in common is that they're divisible by 3, right? They're divisible by 3, so we can scale them down a little bit to make them easier, right? So we can divide through by 3 to make the question much easier. So we divide this by 3. You can always check for that, by the way, guys. If you can divide through by a similar number to make it smaller whenever you're trying to find an x value, all right? And we divide through the 0 by 3. All right, cool. So in that case, 3 divided by 3 is just going to be equal back to 1. So when I need to put back the 1 there, x squared minus 3 divided by 12, right? Yeah, that's what's going to be equal to 4. 4x 3 divided by 9 is going to be equal to 3. And 0 divided by 3 is just going to be equal to 0, right? So now we have a nice equation. We can find our x values relatively simple, right? Nothing that causes any headache or anything like that, right? So we need to find the x values that when added or subtracted, it gives us -4, and when multiplied, it gives us back +3, right? So then we ask ourselves, which two values can we use, right? We realize that we can use 3 and 1, but not just any 3 and 1, but -3 and negative, sorry about that. Yeah, -3 and -1, right? Because when you multiply -3 by -1, it'll give us back the 3. And when you have -3 minus -1, will give us back -4, right? So those are the two values that we'll be using in order for us to find our x values, right? So now we can say that we can say x squared, and what are the values? We'll just put them up here. So -3, -1 are the x values that we'll be using, right? We can say -3x minus x plus 3 is equal to 0, right? And now we factorize it to make it smaller, and then we find our x values right after, right? So now what's common between these two? We can see x is common, right? So put our x outside. We'll say carry the x out, divide through by x, give us back x, minus divide through by x again, gives us back 3, close bracket, minus 1, common factor again. What's the common factor between -x and +3? This is -1, right? And then we put right on, yeah, cool, right? So then we put back our x minus 3. Guys, if we really want to know if we're doing the right thing, one thing to check or to ensure that you're doing the right thing, you see where you have the x, where the pointer is at right now. See, once here, once these two values, once the two things here, what's in the bracket is the same. Let me just use a different marker, different color. Once it's saying the same thing, once this and this here are equal, you know say I did the right thing. If they're not equal after you factorize, then you know say you do something wrong. they must always be equal to ensure that you're doing the right thing. Because if they're not equal, you did something wrong. You need to retrace your steps and fix your error so you actually arrive at the correct x values that you need, right? So we see where what's in the bracket here and what's in the bracket here are equivalent. So we know that, hey, we're doing the right thing. So we can continue and find our x values, right? So we say x minus 1 brackets x minus 3 equal to 0, right? So we can easily determine our x values. You guys should be seeing it right now, where we see our x is equal to 1 and our x and our x is equal to 3, right? And these are our stationary points. These are the stationary points that we need. So let me just put these right here. So stationary points. All right. So these are our stationary points right here. Can just circle a little bit. All right. All right. These are our stationary points. Our stationary points are x is equal to 1 and x is equal to 3, right? And you don't have to work it this way. You have so many different ways you can find the x values. But for simplification, this should be one of the quickest ways you can find it, right? But if you're comfortable with another method, in regards to maybe using the formula, maybe simultaneous equations. No, not simultaneous equation. Sorry about that. The formula or any other method that you like or feel comfortable finding x values, you can apply that. All right, but personally, I think most persons should be used to this method. Relatively straightforward, really simple to understand. Right? So we found our stationary points, right? The second part of the question now, it asks us to go right here, right? Second part of the question is asking us to find the coordinates of our local maximum and our local minimum, right? Right? So how do you know when something is at maximum or when you know it's at minimum, right? It's at maximum if our f of x double prime x is less than 0, and it's at minimum if our f double prime x is greater than 0. And when I say double prime, you should all know what I'm talking about, but meaning that you're differentiating twice, right? So you differentiated once. We got the answer in our previous question. We differentiated the question once, and you're going to differentiate again, and then you substitute the x value in order for us to determine whether or not it's greater than or less than 0, to find out if it's a maximum, local maximum, or a local minimum, right? So we remember from our original question that we differentiated, we got the differentiation of f prime x is equal to, what's that, 3x squared minus 12x plus 9. Cool? That's the first differentiation that we got, right? But in order for us, as we said before, to determine our local maximum or our local minimum, we need to differentiate the function twice, right? So we need to differentiate this again, right? So put part 2 right here, so cool. All right, so we're gonna differentiate it one more time. F double prime x. Differentiate this again. Same thing we've been doing. Carry down the function, minus 1 from the function, right? So carry down the 2, we're gonna get 2 times 3, which is equal to 6, multiplied by x, minus 1 from the function is gonna give us back 1, minus 12 to 12 minus 12x, the differential of 12x, right? Is just gonna be equal to 12. Right, so this is our differentiation. We differentiate twice. We differentiate original function twice. We get 6x minus 12, right? So now we've done one part of the question. So we're really close to finding our maximum or our minimum, right? So the question says when x is equal to 1. I remember that we got our stationary points, right? So to find our local maximum or our local minimum, we need to substitute the values, our x values that we got from our stationary points into our differentiation right here, f double prime differentiation, right? We need to substitute those values and then determine if they're greater than or less than 0, right? So from our previous question, we worked out and we got x is equal to 1 and x is equal to 3, right? So let me just put that right here. So we could do, all right. So where x is equal to 1 and x is equal to 3. What's going on here? All right, cool. Yeah, man. Where x is equal to 1 and x is equal to 3, right? So all we're gonna do right here now is plug and chug, right? We plug our x values into our f double prime x to determine our local maximum, our local minimum, and our local minimum, right? So now we plug our first x value of 1. So plug f double prime 1 equal to 6, 1 minus 12, right? So 6 times 1 is going to give us back 6 minus 12 equal to negative 6, right? So then we ask ourselves, is this greater than or is this less than 0? Right? Is this greater than or less than 0? Hold on, let me carry this up right here. So cool. All right, cool. All right. So we ask ourselves, is this greater than or is this less than 0? We realize that negative 6 is less than 0, right? So I would say because negative 6 is less than 0, we no, don't say that. Can I say this? We can say we conclude that this is a local maximum, right? So because negative 6 is less than 0, we conclude that this is a local maximum. Cool. So now we substitute the next x value and see if it's a local maximum or a local minimum, right? Let's draw a line right here. So cool. So we say that f double prime, the other x value is x equal to 3, right? So x is equal to 3. equal to 6 bracket 3 minus 12. 6 times 3 is equal to 18. So we have 18 minus 12, which is equal to positive 6, right? And realize that the positive 6 is greater than 0. And because it is greater than 0, we can conclude that this is a local minimum, right? So now we just write our little statement right here saying that because negative, sorry about that, because positive 6, so let's put the positive 6 is greater than 0, we conclude that, oh wait, hold on. All right. Yeah, I'll just write that over because positive 6 is greater than 0, we conclude that this is a local minimum. All right, no tricks. We conclude that this is a, all right, cool. Oh, I see what happened there. All right, yeah. So no tricks. Is anyone unclear with what we just did? Or is everybody good?
Yeah, man, good man.
All right, cool. All right. I don't think the paper is finished. See, this is page 7 of 8. But I don't have the full last part of the question here. I don't have the full last part of this question. So we're just gonna work the next paper and then wrap up. Cool. All right. So let's clear the board real quick. All right. This is a 2017 paper. All right. So let's go work the 2017 paper and call it a night. All right. So we just finished the 2016, working the 2017 now. All right. So you guys aren't getting any matrices or anything like that, so we can skip the first part of the paper. All right, so I'm just go right to the differentiation part, right? And as we previously stated, our product rule, our quotient rule, I'll write it back in the question again, just for refreshment, right? So we see the question number 2 asks us to find the f prime, the differentiation of f of x for the following functions, right? And it says that we don't have to simplify our answers. So the first one, it asks us of f of x equal to the square root of x cubed plus 1. We need to find the differential of that, right? So we can pull up the whiteboard. All right, 1 second. All right, so number 2. Number 2 asks us, the function gives us a function of f of x equal to the square root it's not correct. X cubed plus 1. All right, but we need to find our f prime x, right? So whenever you're given a square root function and you need to find the differentiation of that square root function, the first thing I would definitely advise you to do is to convert that square root into into numbers, right? So you know, square root is also can also be written as a half, raised to a half. If a function is square rooted, it can just be written back as a half, the power of a half raised to the function, right? So in this case, we can rewrite the f of x square rooted x cubed plus 1 as our x cubed plus 1 raised to a half, which is the same thing as the square root of the function. Cool. Same thing as the square root. And we can realize that this looks like the usual function that we would differentiate if we have more than one function being added or subtracted together in a bracket, and we have that being raised by a power, right? So in this case, all we need to do is to carry down the power, minus 1 from the power, and then multiply what's in the brackets by the entire function, right? So let's do that step by step. Carry down the power of a half, multiply that by what's in the brackets, x cubed, 1, x cubed plus 1 raised to a half. Half minus 1, right? 1. Sorry about that. So we're going to subtract 1 from a half, right? That's just going to give us back negative a half, right? So we're going to put this raised to negative a half being multiplied by the differential of what's in the bracket, right? So we have x cubed plus 1 in the bracket. Find the differential of that. The differential of x cubed, we're going to carry down the power and multiply that by x, and then minus 1 from the power, right? And that will give us 3x squared. And remember that we said that the differential of a whole number is just going to give us back 0. Zine. So we just put back the differential of the what's in the bracket being multiplied. I'll just bracket that instead. Multiplied by 3x squared. And that's it. All right. They say that we don't need to simplify it, but we can just, it's easier. This just gonna look like 3x squared divided by 2. Let's make it neater. X cubed plus 1. All of that's raised to negative a half. And that is our answer. Cool. That is our answer.
Excuse me.
Yeah, hearing you.
How did you get the negative half? I got up for a bit there.
All right. All you're gonna do, because it's a power and we're differentiating, you're gonna minus 1 from the power, right? So negative 2 minus 1 to give us negative a half.
Oh, okay, I got it. Thanks.
Yeah, no problem. All right. So now that would basically complete part 1 of question 2, right? Part 1 of question 2 completed. And part 2 asks us to find the differentiation of, write it here, right? Part 2 asks us to find the differentiation of f of x is equal to e on is equal to e raised to the power of 7x times ln 4 minus 5x. Cool. So it's asking us to find the differentiation of this function, right? But here we look at it, realize that there's more than one function in this entire function. So there's, let me use the pointer. We have the first function here, which is e raised to the power of 7x being multiplied by a second function, which is our ln bracket 4 minus 5x, right? And what do we say when we have a function being multiplied by another function? We're going to use the product rule, right? So we can't just go about our usual carrying down the function minus 1 from the function strategy. We have to analyze the question carefully to ensure that we're always using or applying the proper method of differentiation. Cool? So in this case, we need to apply the product rule, right? And what if I have space here? So I'll just clear it here. So all right. I guess it's going to work. All right, I'm gonna just carry this over. All right, cool. So now we write our product rule function. All right. Let me see if I can just type it just instead, make it easier. All right. So it's a product rule. Cool. So the product rule, as we know, is our first function, or the second function rather, second function of x zero superscript here. Okay, cool. Yeah, second function of x multiplied by our first function, the derivative of our first function of x there, plus our first function of x multiplied by the derivative of our second function of x, right? That is our product rule, right? So all we need for the now, we need to determine what our u and our v is. So remember we said that our u and our v, the u is our first function, the v is our second function. So our u is equal to the first function, which is the e raised to the power of 7x, and our v is our ln bracket 4 minus 5x. Cool. So we need to find our u prime and our v prime, and then plug in those values to arrive at our answer. All right. So we say that since our u of x is equal to our e raised to the power of x, our u prime, hold on, plug this real quick. All right, our u prime is going to be equal to, all right, so this is the e now, right? Remember what we said about E functions? All we're gonna do is to differentiate the power, and after we differentiate the power, we carry down the differential and then multiply it by the original function, right? So we differentiate the power. What's the power? The power is 7x. The differential of 7x is just gonna give us back 7. And then we carry down that differentiation, which is equal to 7, and multiply that by the original function, which is e raised to the power of 7x. Cool. So that's our u differential x. And then we now find our v prime. So we say our v of x equal to ln bracket 4 minus 5x. Now we need to find our v differential x, right? So because it's a ln now, based on the rules of differentiation, to find the differential of something that's in ln form, we need to find the differential of what's in the brackets and divide that by what's in the bracket. So find the differential of what's in the brackets. We said that the differential of a whole number is just going to be equal back to 0. And then the differential of negative 5x is just going to give us back negative 5. So in that case, we're going to have negative 5 divided by what's in the bracket. What's in the bracket is 4 minus 5x, right? So that's our v prime, or v differential of x, right? So now that we've already have our values, all we need to do now is to substitute our values into our product rule in order for us to arrive at our answer, right? So now we say that the first part of the product rule, we have our v of x and u prime. And guys, just a note, you don't need to start off like this, right? You can also have this. The product rule doesn't need to be necessarily be written like this. It can be written like this as well. U x is the same thing. V prime x plus vx times u prime. If you realize it's the same thing. I've got some questions, some persons sometime that why did you write it like this? Isn't it supposed to be written like that? But if you realize it's the same thing, it's saying the exact same thing, no matter how you want to put it, right? This and this is the same thing. So now we need to substitute our values in order for us to arrive at our answer. Cool. So we have our v of x, which we said is equal to ln 4 minus 5x, right? So let's put it right here. So say ln 4 minus 5x, right? And our u prime is equal to 7 e 7x, e raised to the power of 7x, right? Plus our u is given as e raised to the power of 7x, and multiply that by our v prime, which is equal to negative 5 divided by 4 minus 5x, right? And you'd stop right there. You definitely see this in your multiple. You definitely see this answer in a multiple choice. It's not usually required to simplify. To simplify, not really take much time, but yeah, this is where we can stop right here. So we'd have our answer right here for our v prime. All right. You guys have any questions? Is everything clear, or you need me to go over something?
Go back over the part where you differentiate the V.
All right. So we said that our V, which is our second function, is equal to ln, open bracket, 4 minus 5x. Cool. And when you're finding differentiation of an ln function, we need to find the differential of what's in the bracket and divide that by what's in the bracket, right? So let's use a simpler function, right? Let's say we have ln is equal to 5x, right? 5x. Find the differential of that. To find the differential, we need to find the differentiation of what's in the bracket and then divide that by what's in the bracket. So we can always start off by something that we know that will always be there. But always divide by what's in the bracket. Always for the differential of ln. So we can put back the 5x there. So the 5x can be there in whichever case, right? So we have our 5, and then we're going to differentiate what's in the bracket. And the differential of 5x is just going to give us back 5, right?
Yeah.
And that will just give us the differential of our ln function. And that's the same thing that we applied right here. Yeah, we just put back what's in the bracket and then differentiate what's in the bracket.
All right, respect.
Yeah, man. All right, cool. So that is our answer for part 2. And we can move on to part 3, right? So I'm gonna just clear this off, right? Pull up part 3 real quick. All right. So part 3, where it has f of x is equal to 2x cubed divided by x squared plus 3. And remember that we said that whenever we have a function being divided by another function, we apply our quotient rule, right? So in this case, we have part 3, we have f of x is equal to 2x cubed divided by x squared plus 2. See? And we realize that we have a function being divided by another function. So automatically we're gonna know, say, all right, quotient rule time, right? So we just write the quotient rule right here. So quotient rule. I'm gonna put this in block. All right. Quotient rule, right? So our quotient rule states that we'll have our first function, or second function rather, second function of x multiplied by the differential of our first function of x minus our first function of x multiplied by the differential of our second function of x, right? And all of that are going to be divided by 1. All of that's going to be divided by our second function, square of our second function. So let me just use this. Our second function is v brackets x close brackets, brackets, carry this over. All right, that now makes sense there. So yeah, that's great. Cool. So that's our quotient rule. So our v values, our v and u values, our u is our numerator and our v is our denominator, right? So we see where our u value, which is our numerator, u x is equal to 2x cubed. Cool. So we need to find the differential of this now, where we say the differential of u of x is going to be equal to, you have the power, carry down the power, minus 1 from the power. So carry down the power, 3. 3 times 2 is going to be equal to 6 times x minus 1 from the power. Just gives us back 2, right? And then we have v now, which is our denominator, our v of x equal to x squared plus 2, our v prime now, our v differential of x is equal to carry down the power minus 1 from the power equal to 2x. And we know that the differential of a whole number is just going to give us back 0, right? So all we need to do now is to plug in our values in our quotient rule equation, and then we have our answer, right? So now we start off with let's put this in a nice. All right. So I'm gonna use the quotient rule now. Hold on. No sense. All right. Better. All right. So use our quotient rule now. All right. So we substitute our values. Our v of x, where is our v of x, is equal to x squared plus 2 brackets multiplied by our u prime x, which is equal to 6x. And I'm sure you guys realize that if I say u prime, is just another way to say the differential, right? Just another way to say the differential. Minus our u. Our u is equal to 2x raised to the power 3 multiplied by our v prime x, which is equal to 2x. And all of that being divided by the square of our second function of v of x. All right. So our second function, as we said, is equal to x squared plus 2, and you just need to square that. And then we'll have our answer. All right. And that's how we arrive at our answer. Any questions or anything I want to go back over? Everything good. All right. So we can move on to the second question now. All right. So the second question asks us to find the gradients of curve y is equal to 4x squared minus x plus 1 at the point 2 and 1. Now, when it's asking you to find the gradient of a function, it's asking you you can find the differentiation of the function. Of the function is equal to 0, right? So all it's asking you to do is to find the differentiation of the function and then plug in the values that they gave you, which are the 2 and the 1. We know that the 2 is equal to x and the 1 is equal to y, right? So let's find the differentiation of the function and then plug in those values that they gave us. All right. So the function now. All right. So the function is given as y is equal to 4x squared minus 8x. Oh, want something right here, so cool. All right, it's x plus 1. All right, so we need to find the differential of this. All right, so oh wait, also add at, can just type this in right here, so at the points 2 and 1. Okay, let's look a bit closer. All right, so we need to find the differentiation of this. All right, so we have our y and we have our x. All right, so we're going to say the differential of this is going to be equal to dy over dx on dy over dx. Same thing as differential. You're going to differentiate the function now, right? So we carry down the power, minus 1 from the power. So we carry down the 2. 2 times 4 is equal to 8. 8x 2 minus 1 gives us back 1. We don't need to write it back though. And differential of 8x is just going to give us back 8. And the differentiation of an whole number is going to give us back 0, right? So now that we have our first differential, we can plug in our values and then find the gradient, right? So we can say that, so we can say at the point where two and 1 hold on, can type that our gradient, which is dy over d of x, is going to be equal to where we have 8. What is our x? Our x value is 2. Go back to 2 and minus 8. We don't need to use our y value because we don't have any y in this equation, right? We just have x, so we just need to plug in our x value. So we say 8 times 2 is equal to 16. 16 minus 8 gonna give us back 8. Cool. Right. So we can now say that therefore our gradients is 8. All right, and this will complete part A of the question, where it asks us to find the gradient. Oh dear.
So hold on there. So how you come by the 8x minus 8? I was distracted.
The 8x minus 8. All right. So all we did was differentiate the original function, right? So the original function as given is equal to y is y equal to 4x squared minus 8x plus 1. So all we did was to differentiate that. So we say differential of 4x squared, you're going to carry down the power of 2 and multiply that by 4, gives us back 8. Multiply by x, and then you're going to minus 1 from the power. 2 minus 1 gives us back 1. This is the same thing present on back. Yeah. and then you differentiate 8x, which just gives us back 8. And that's how we got the 8x minus 8.
All right, respect.
Yeah, man. So we have our gradient. So this is part 3, section A. There, cool. So we have our gradient is equal to 8. So we can move to the second part of the question since we found our gradient, right? So second part asks us to find the coordinates of the point at which the tangent to the curve in part A is horizontal. Now, it's important to note that when, pull up the whiteboard. All right, let's clear this off. All right, so 3B, right? So it says to find the coordinates of the point at which the tangent to the curve at part A is horizontal. Now, in order for it, if it's tangent, right? In order for a tangent, or when a tangent is horizontal, the differential is equal to 0. So all it's asking you to do is to equate the differential that we just found, equate it to 0, and then solve for our unknown variable, our variables. But in this case, we only have one unknown variable, and that is x, right? So we can make a little side note. I would say one. All right. So when tangent is horizontal, or dy over dx is equal to 0. Cool? Always, right? So now, with that said, we can write back our original differentiation that we literally just found, right? Which is our dy over dx is equal to 8x minus 8, right? And all we need to do now is equate it to 0, since our it's saying that our tangent is horizontal, right? So we equate our 8x minus 8 to 0. So we have our 8x minus 8 equal to 0. And then all we need to do right now is solve for our x, right? So simple mathematics. Carry over the negative 8 over to another side. So we have x on a side of its own, or by itself, right? So we have 8x on 8x is equal to, carry it over, carry over the negative x, negative 8. So we're going to have positive 8, right? So in order for us to find x, we need to divide through by 8, since they're both divisible by 8. So we just divide through by 8. 1. Oh gosh. Cool. All right. Laptop, I try to give him a fight, but all right, mod. So we divide through by 8. So this cancel out, give us 1. This cancel out, gives us back 1. Right? So we can therefore conclude that our x is equal to 1, right? As we just determined, right? Our x is equal to 1. But are we finished? No, we're not finished, right? So after we have solved for our x value, now we need to plug in that x value into our original equation, right? Now, what was our original equation? I'll write it back right here. All right, so our original equation, as was given in the question, it has y, where y is equal to 4x squared minus 8x plus 1. Cool? That's our original equation. So in order for us to find the coordinates of the point at which the tangent curve, right, is horizontal, we need to plug in our x value, which we just found, into our original equation so that we can find our y value. Because we already found the first coordinate, but we need to find the second coordinate now, which is our y, right? So I go plug and chug. We'll plug, sorry about that. We'll plug in our x value into our y equation to find y, all right? So we're going to say now, y is equal to 4, plug in our x is equal to 1, square minus 8, we'll say x equal to 1, plus 1, all right? Simple mathematics, simplify, multiply through the mid simplify. So we have y is equal to 1 raised to the 1 square, still gonna give us 1. 1 times 4 gives us back 4. 1 times 8 gives us back 8 plus 1, all right? So we have, so therefore, our answer, our y, is gonna be equal to -3. So we have our second coordinate now, which is our y. So now we can state that coordinates, our coordinates are brackets x1, comma, -3. And those are our coordinates, right? Is everyone clear? Or is there any questions before we move on? Or everything good? All right, like a beer bright spots another class here, man. All right, good luck, good luck, good luck. All right, so we can move on to question 4. So I'm just clear the board. Pull up question 4. All right. All right. So question 4 now. So we're almost finished. All right. So question 4 now. Similar to what we did in the previous paper, right? It says the total cost of manufacturing X units of a particular commodity is given by, gives a function, C of X is equal to 1/8 multiplied by X squared plus 3X plus 98, right? $98. All of that is going to be equal to one singular figure, right? So the unit is dollars. Cool. And it's asking us to find the marginal cost function, right? So what did we say whenever it asked us to find the marginal cost? If it's asking you to find the marginal cost of a function, in this case, it's asking you to find the differential of the function, right? So it's asking you just to find the differential of this function, right? So we'll just go back to the whiteboard. We'll just work that. See? No trick so far. And guys, it's really not gonna get much harder than this in the exams, really and truly. More than likely, as Suarez teach most persons in here. If not, I'm not sure the other tutor is. Not tutor, lecturer rather. It's not not gonna get much difficult than this at this level right now, right? So we're gonna write about the function. Function, question 4. Right? Question 4, part I. Function given is C x is equal to 1/8. Oh man, this doesn't look right. Cool. 1/8 multiplied by x squared plus or 3x plus $98. All right. So we have a nice little function right here. So now it's cool. This if we find the marginal cost. So we say the marginal cost be again. The marginal cost of a function in this case is the differential of the function. So our c prime x, c differential x. So I can find the differential of the function above, right? So we see 1/8 multiplied by 1/8 x squared, right? So we're just gonna carry down the function, same thing we've been doing. Carry down the power rather. Carry down the power, minus 1 from the power. So we carry down the 2, right? So we're gonna get back 2 multiplied by 1/8. 2 multiplied by 1/8, it's gonna give us 2/8. We simplify that, give us 1/4. 1/4. That's 2 into 8 gives us 4, of course. And then right about the x, 1 minus the power gives us back 1. We don't need to write that back. Plus 3, the differential of 3x just gonna gives us back 3, right? And let me just fix this up. All right. All right. Carry this over a little bit. All right. So we said that it asked us for marginal cost. So the units for our answer is going to be equal to dollars. Yeah. So I try to find some money. So let's say $1. All right. So that is our answer. Cool. The second part of the question now. All right. So that's part I. Second part. 1 second. All right. Oh, on the wrong paper. All right. Second part now asks us to use the marginal function to estimate the cost of producing the 9th unit, right? So if we're going to estimate the cost, if we're trying to determine the 9th unit, in order for us to determine the 9th unit, we need to find the 8th unit, right? And same applies if we're trying to find the 100th unit. In this case, you need to find the 99th unit in order to find the 100 unit, right? So I'm gonna just clear out the board. So in this case, you need to find the eighth unit in order to determine what the 9th unit is or will be. All right. So we're just gonna plug in 8, x is equal to 8 into our differential function. So part 4, second part. So we already determined that our c prime x is equal to 1/4 times x plus 3. Cool. And we said that we want to find the 9th unit. And in order to find the 9th unit, we need to find out what the 8th unit is, right? So we're going to plug in where x is equal to 8th, right? So you're going to say 1/8 Let's put this right here. So all right, so give me some problem. Let's fix this. All right, let me just take this off and just type it. Much easier. I should have this in the first place. So we're x equal to 8. All right. I can just delete this right here. So good. So where x is equal to 8, but substitute the values in order for us to determine what our 9th unit is, the cost of our 9th unit rather. All right. So we plug in our x value. So it's a c prime. We'll say x equal to 8. On x is equal to 8 equal to 1/4 x equal to 8 plus 3. Cool. Then the simple mathematics. 8 times quarter is equal to 8/4. Then we just divide that by simplify that by dividing through. So 8 divided by 4 is equal to 2. So we just come get back 2 here. So 2 plus 3. And that's going to give us our c prime 8 is just going to be our marginal cost of 9th unit is just going to be equal to $5. No tricks. And that's how we find the marginal cost of our 9th unit for part 2. All right. If you have any questions, feel free to stop me or anything so I can go back over something if you never got it. All right. So we'll just work the second part of the question now. So what is the second part? The third part rather. Right? So what does the third part of the question ask us? It asks us what is the actual cost of producing the 9th unit, right? So it's asking about the actual cost now, right? So in order for us to find the actual cost, we need to something need to subtract from something, right? So it asks us the 9th unit. So we need to find the difference between the 9th unit and the unit before that, right? Which is the 8th unit, right? So we're gonna minus where c is equal to 9 minus where c is equal to 8, right? In order for us to find the actual cost of the 9th unit, right? So the third part, we already have our c function. Our c function is equal to cx equal to 1/8 x squared plus 3x plus 98. All right. So we say we need to find the actual cost of the 9th unit now. So we need to find where so actual cost is gonna be where x is equal to 9 minus c where x is equal to 8. That's how we find our actual cost, right? So we just gonna plug and chug, right? So when you plug I don't think I need to write this out. Just simple basic mathematics. You substitute 9 into our original function of c of x, right? So we just do that real quick. So it's a 1/8 multiplied by 9 square plus 3 multiplied by 9 plus 98, right? So we're gonna have where C9 is equal to 135.125 minus where C is equal to 8. So we just gonna plug in the 8, and that will give us 130, right? Right? So after we've done that, all we need to do, just subtract the two figures, and we're going to get our actual cost. We'll just say AC. AC actual cost is equal to $5.13 after a roundup. Right? All right, that look a bit better. Is equal to $5.13. Right? And that is our actual cost of producing the 9th unit. Right? Have our actual cost here. Let's put the marginal cost here. Yeah. So before we move on, anyone have any questions? Or is everything clear? All right, so nobody now responds, so everybody good then. All right, cool. So we can just clear the board and just work the last two, or the last question. That's 2 parts. All right, so we just show the last question now. Last question, number 5, says you are given the function f of x is equal to 2x cubed plus 3x squared minus 12x plus 1. Find the coordinates of the stationary points of f of x. Key term, stationary points. What did we say in our last paper when it's asking us to find the stationary points? It's asking us to find our x values, right? Oh, sorry about that. Yeah, it's asking us to find our x values, right? So now, in order for us to find our x values given this particular equation, we need to differentiate it, right? We differentiate it, we make it a little bit simpler for us to work, and then we take it from there in regards to finding our x values, right? So now, pull up the whiteboard again. Right about the function given, question 5, part for I, function f of x is equal to 2x cubed plus 3x squared on 3x squared minus 12 plus 12x rather plus 1. Cool. So that's the function given. It's asking us to find the stationary points. So now we say, all right, cool, stationary points. Let's find the differential, and then we solve for x values, right? So the differential of this function, we say f prime x is equal to differential of this. First thing, 2x cubed, carry down the power, multiply by that, then you minus 1 from the power, right? So carry down the 3 times 2 gives us 6x on 3 times 2 gives us 6x minus 1 from the power, gives us 2. So 6x squared, right? Plus 3x squared. Carry down the power. 3 times 2 gives us back 6 again. X and 2 minus 1. 1 from the power. This gives us back 1. We don't need to write that back. Minus, what's the third one? 12x, right? 12x, the differential of that is just going to give us back 12, right? And the differential of a whole number is going to be equal to 0, right? So we have the differential. Now we need to find the x value, right? Our x values rather, which are our stationary points, right? So to find our x values, we need to equate the function to 0 and then solve for x, right? So we equate the function to 0. We have 6 6x squared plus 6x minus 12 equal to 0, right? But if you realize this function can be broken down into a smaller function, right? You realize that each values are divisible by 6, right? So in order to make it much easier and less tedious on our side, if we realize that it's divisible by a similar number, then we divide through by that number to make the working out much easier. So in that case, we can divide through each of this by 6, right? So we divide through by 6, and we'll go so boom. Divide by 6, divide by 6, divide by 6, and divide the 0 by 6 as well, right? And when we do that, 6 divided by 6 just gives us back 1. So we just have x squared here. So same thing again, 6 into 6 gives us back 1. We just have x. 6 divided by 12 gives us back negative 2. And 0 divided by 6, it just gives us back 0. Right? So we have our nice little function right here. So nothing too hard, nothing too rough. Easy for work out, right? We can look at this function and even determine our x values, right? We can see that our x is going to be equal to 2, and x is going to be equal to 1. So x minus 2 multiplied by x plus 2 multiplied by x minus 1. Cool. But even though we can see it, we just work it just the same, right? So we say that which two numbers can we multiply? That when we multiply them, we get negative 2. And when we add or subtract, we get positive 1, right? What are those two numbers? We can see that those two would be equal to positive 2 and negative 1. Positive 2 times negative 1 gives us back negative 2. Positive 2 plus, positive 2 negative minus 1 gives us back 1, right? So therefore, that would satisfy the criteria that we'd be looking for. So we can we can write that now in our equation, so we can be one step closer to finding our x values, right? So we say, all right, the two values we're going to use, what are they? 2 and negative 1, right? So let's put that in the equation. So we say x squared, right? And we say plus 2x minus x, or negative 1x, same thing, minus 2 equal to 0, right? So we just factorize now. I would say, all right, what's similar between these two, x squared and positive 2x? You realize that the similarity between those are x. So we'll put x outside. I would say x, we divide through by x, gives us back x, divide through by x again, gives us back 2. And we can put minus 1 here, as we're factoring out the similarities between these two values. And we have x plus 2 divided through by negative 1 gives us back x divided through by negative 1 again, gives us back positive 2. Equate that to 0. Remember that I said that to ensure that I'm doing the right thing. Hold on, write this part better. All right, to ensure that you're doing the right thing, what's in the bracket here and what's in the bracket here should be the same thing. If they're not the same, then you do something wrong. I need to retrace the steps and find out where you made the error, right? So in this case, you realize that both of them are the same. So we know, say, all right, cool, we did the right thing. So we can just continue and find our x values, right? So we say, all right, cool. We have x minus 1, and then we have x plus 2, right? Equal to 0. And from this, we can easily see that our stationary points, the points where stationary points are x is equal to positive 1 and x is equal to negative 2, right? Those are stationary point values. Just write stationary point right here. So our stationary points are x is equal to 1 and x is equal to negative 2, all right? And that's how we find our stationary points. And the last part of the question, very last thing we'll be doing tonight, let's pull up the question. It says that we are to determine if each stationary point is a local maximum or a local minimum. And remember that we spoke about the local maximum and local minimum in the last paper. We said that in order for the f double prime x to be a maximum, it needs to be less than 0. And if it's a minimum, it needs to be greater than 0, right? So we're going to determine that if it's a maximum or if it's a minimum, right? So now we have our f. We don't need to delete every single thing. We just delete delete this. All right. All right. So we have our f prime, which is here, right? So in order for us to find or determine if the stationary points are a local maximum or a local minimum, sorry about that. All right. Yeah. So as I was saying, local maximum or local minimum, we need to differentiate twice. We need to differentiate the original function twice and then substitute our stationary points into that differential that we found, right? So we already differentiated. We already did the first differentiation already. So we just need to differentiate it one more time, right? So we say f double prime x is equal to, all right, simple differentiation, same thing we've been doing. Carry down the function, multiply, then minus 1 from the function. So the function is 2, carry down the 2, multiply the 2 by 6 gives us 12, and then minus 1 from the function, one from the 2 rather, which will just give us back 1, right? So we'll just do that right now. So we carry down the 2, 2 times 6 gives us 12. 12x minus 1 from the function, minus 1 from the power rather, gives us back 1, right? So we don't need to worry about the 1 here. It's still saying the same thing. Plus the differential of 6x is just going to give us back 6. So plus 6, and the differentiation of a whole number is just going to give us back 0. So we don't need to write that back, right? So we have our double differentiation, right? Well, our f double prime x, right? So now all we need to do is to plug in our stationary values. So we already determined our stationary values, our stationary values. Let's put it back right here. So where x is equal to -2 and x is equal to 1, right? So these are stationary values. All we need to do right now is to plug those x values into our original equation, into our f double prime x to find out if it's a maximum or a minimum, right? So we're going to do that right now. So we say that it's a f double prime x, wait, arrow. So we say f double prime -2, where since we're substituting the x value, it's going to be equal to 12, where x is equal to -2 plus 6, right? Or plus 6, right? So we can multiply through. -2 times 12 gives us -24 plus +6. Gives us +6, and that is going to give us -18. All right. So we can already see that -18 is less than 0, right? So we can jot down our little conclusion, right? So we say because f double prime x, f double prime -2 is, which is -18, is less than 0. It is a local maximum. All right. So because it is less than 0, we can conclude that it is a local maximum. All right. So now we can work where x is equal to 1. All right. So we can just draw a line here. So 1. Can draw a line right here. Now we say, all right, f double prime, we say where x is equal to 1 is equal to 12, where x is equal to 1 plus 6 is equal to 12 times 1 gives us back 12 plus 6 that gives us back 18. Right. So is 18 less than or greater than 0? We can see where 18 is greater than 0, right? So we can just write a little conclusion right here so as well, stating that because our f double prime x, which is positive 18, is greater than 0, it is a local minimum. And that's how we find our maximum. Well, determine if it's a maximum or if it's a minimum value, right? And that will wrap up the session from tonight. Anybody have any questions before I conclude? Have any questions, query, anything you're not sure about? All right, so I guess everybody good. All right, so we can clear the board. We can stop share. All right, guys. So I hope the session was helpful, or it helped to clarify some things to everyone. I really hope that you guys enjoyed it. The recording, it's been recorded, right? So it will be posted, hopefully, if not by tonight, early in the morning on FSS Guild Media YouTube channel. So you guys can check it out if you want to go over something or rewatch something for further clarifications, right? And you can also reach out to me or the host or any member of the faculty guild committee or the faculty's honor society or the Chance to Uplifting Brother Society if you have any further questions of anything that was done here tonight. All right. Well, that's it, guys.
So you tell me if I know to do everything that we went through today, I should be able to pass.
All right. Bear in mind that these are the past papers. You guys say getting from limits straight up to the last topic. This covered differentiation, mainly differentiation. I do recommend though that you practice the problem sets. Don't just practice the past papers. The past papers are good, but don't just depend on practicing the past papers to pass. It's really important. Trust me, I'm speaking from experience. If you can do the problem sets for the topics that you're getting on the exam, and you can do the past papers, then you have a high chance of passing. Trust me. We could have done the problem sets tonight, but that would have taken a longer time since that there are a lot of topics, right? But recommend that you do the problem sets. You can watch some YouTube videos as well to help you further clarify, because those are really helpful, and as well as the past paper that was worked here tonight, right? So once you do all of that, you're supposed to good. The exam more than likely not gonna hard, trust me. Once you practice, it shouldn't be hard once you practice.
Okay, thanks a lot.
Yeah, man, no problem. All right, guys. Good night and all the best in your exams.